Welcome to 24 Hours of Past Summer Preview. We're excited you could join us today for Brian Knight's session, Performance Tuning SQL Server Integration Services. This 24 Hours of Past event consists of 24 consecutive live webcasts. Sessions will be recorded and posted online soon after the event. My name is Robert Davis. I am a SQL Certified Master and MVP and know very little about SSIS compared to Brian. I have a few quick introduction slides before I hand over the reins to Brian. He will speak for 40 to 45 minutes, and then we'll move to the Q&A where you can ask any questions you have. If you're having any issues, type your issue into the question pane and someone will assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. Feel free to enter your questions in the Q&A field at any time. The questions pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. As a side note, if you are having any connection issues, you may want to try closing out the webcam window to increase your bandwidth. I want to take a moment to thank our sponsors. The staging a 24-hour pass would not be possible without their support and dedication. They are the reason the event is available free of charge. Thank you to our presenting sponsors, Microsoft and Dell Software. Next, as you may know, this 24 Hours of Past is a preview of Past Summit 2014, the largest conference for SQL Server and BI professionals. With over 5,000 attendees representing 2,000 companies from 52 countries, Summit is a time to share, connect, and learn with your peers and industry partners. Past Summit is not only a week of intensive learning and knowledge sharing that will offer strategic insights, it's a time to network and rub shoulders with industry experts. Taking place in Seattle, Washington from November 4th through the 7th, Past Summit will feature over 190 world-class sessions across 5 topic tracks. These 24 hours of past sessions provide a mere glimpse of what you can expect from Past Summit. Find out more at www.pastsummit.com, and if you register by September 26 using discount code 24HOP14, you'll get $200 off the registration fee. Now I'd like to introduce you to Brian Knight and turn the reins over to him and let him present his session.
Well, thank you, Robert. Appreciate it. Let me go ahead and get started by making you, my Twitter handle is on the address on the screen right now. It's @BrianKnight. So in case you have any questions, of course, you can ask Robert there. You can also ask him on Twitter. I'll kind of keep an eye on my Twitter tweet deck on the side here to get that going as well. So, but please feel free to ask questions at any time. My name is Brian Knight. I'm a SQL Server MVP out of Jacksonville, Florida. I'll just advance slide here real quick. There we go. Okay, and I am the founder of Pragmatic Works, where we do business intelligence training tools, and we also do services. Our website is pragmaticworks.com. My email address is bknight@pragmaticworks.com. I've authored 13 SQL Server books, none of which have been published yet, but eventually I hope to sell them in the flea markets nearby. And I blog at a website called bidn.com. That's the BI Developer Network. All right, so in this session, it's an advanced session, so we're hoping that you know a little bit about SSIS already. This is really going to be a 300 or 400 level session where we focus all about tuning the engine. Now we're focused on specifically some of the SSIS internals that make SSIS run and run well and run poorly sometimes. So if you have a package that takes more than 10 minutes to run, this session is most certainly going to be for you. So but it is going to be an advanced session. So if you've been in IT for more than 10 years, you know one of the things you can see as far as the trend goes nowadays, if I were to tell you 10 years ago, I'm going to put a terabyte of data or 2 terabytes of data on SQL Server back in the late 90s, you might have been laughed out of the room. But nowadays, all the machines are basically performing the same way, right? DB2, Oracle, SQL Server, they keep on leapfrogging each other. But now we're expected, if you're a hospital, for example, you're expected to get massive amounts of data, more data than you ever could imagine 5, 10 years ago, into a SQL Server in less time. So because people are relying on these systems more frequently, you don't have as much time to get the data in there. So this session is all about tuning the sources, the destinations, and the transforms to find ways to kind of squeeze that 10 minutes of load time or that 1 hour of load time or an hour or 2 hours of load time down to just a couple minutes, hopefully. So let's start first of all on our sources. And how can we tune these data sources to be much more efficient? Well, of course, in SSIS, the old adage is, when you have a hammer, everything looks like a nail. And the same thing applies here for SSIS. When some developers get a hold of SSIS, they want to do everything in SSIS, including things like sorting and where clauses and all that. Because it's very, very visual, it's very self-documenting, and it's very easy. Well, unfortunately, that doesn't work well sometimes. So you want to choose the best tool for what you can do. So if you're pulling data out of a data source, you want to make sure that you bring data out already pre-sorted if you can. I'll show you what I mean in a moment, how we can do that. You also want to do your joins in T-SQL if you can as well. And things like filtering, maybe casting of data. Do as much in that OLADB source as you can as you're bringing data out. So also, as you're bringing data out, one of the ways of tuning that flat file, if you're pulling data out of flat files, one of the ways you can tune that is with a property called fast parse. Now this is if you have a flat file that has numbers or dates. And in those cases, numbers or dates are basically as you pull the data out of a flat file or a data conversion transform, it is going to check every number and date to make sure that you're not passing a value of A or passing the value of the 13th month of the year, for example. So because of that, we want to make sure that we really, if the data came from DB2, for example, or another SQL Server, for example, that data has already been checked to make sure all the numbers are numbers and all the dates are dates. So if we turn this property on, we can save about 8% per column to bring data out. So using the right tool for the job, and fast parse will ultimately save oodles of time. For example, with fast parse, I was able to save about 40% runtime on a package recently. So very, very cool silver bullet you can use sometimes. The last thing is on the connections. So if you're bringing massive amounts of data over a network, there's inherently some issues there. So one of the things that you have, one of the issues you have is just a classic TCP/IP problem. And with TCP/IP, right, it's going to be very, very chatty. Let me turn this. Sorry, this phone is awfully chatty right now as it goes, as it's rebroadcasting all the tweets and all. Let me just turn that off real quick. Sorry about that. So one of the things we can tune is the packet size. And I'll bring that up in a moment here. I'll actually show you the packet size property and how we can ultimately reduce the network traffic. So let's just jump into a quick demo here first. So let's start with the fast parse property first. So what I'm going to do is I'm going to open up a package, and this is the package I'll be using in the pre-conference at PASS, by the way. All these packages will be used in the pre-conference at PASS. But let's start with this fast parse property here. Oh, fast load, there we go. Oh, that's a fast load, excuse me. There we go. So we're going to show two different data flows, one with fast parse off and one with it on. Now the default property is to have it off. And I'm going to run this package. Now, it's not going to be as impressive of a demo as it normally is because this laptop here is using solid-state drives. So it's already pulling data out quite fast. Let's go ahead and run it real quick just to kind of get a baseline of normal run here. And it's pulling about 1 million rows. And as you can see, we can test the speed of it by sending it to a row count transform or sending it to just a dead end, essentially, whether it be a union all or a row count transform. So right now, we're looking at a runtime of about, let me kind of zoom in down there, looks like about 4 seconds here of runtime. Okay, 4.7, we'll call it 4.5 seconds. So let's try with fast parse off. Let's kind of see how we can do this first. So to turn fast parse on, it's the same package, same data flow, same file. I'm going to right-click on the data flow, and I'm going to say Show Advanced Editor. Now this advanced editor is all the stuff Microsoft didn't really want to show you because it's just so much noise in this that it makes it very hard to see in the UI. So what we can do is we can go to the input-output properties. And again, this session is being recorded, so if you want to do this later, you can most certainly do it later. Now, in this case, I'm going to go to output columns. Now, what we have here, again, this is our green line, our blue line coming out. This is our red line coming out. So let's go to the output columns. Now, we'll see I have a whole bunch of numbers in this file. So if I zoom in, you'll see a property here called fastParse. Now, I went ahead and selected that for every integer and every date. And by doing that, again, what's going to happen is SSIS is going to say, okay, I realize you've already parsed the data. I'm not going to do that extra processing for you. And by doing that, 8% will be saved on reading data out of the flat file for every column you have. So it's a fair amount of overhead being involved here. So let's see. We were at 4.7 seconds before. Let's run this again. Now, traditionally, by the way, when I run this, we'll see this run about 20, 30 seconds. And now we'll see the results now of solid-state drive. All right, so you'll see it's much, much faster, visually at least, from 4.7 seconds. And let's see how we did. We went to about 3.2 seconds, so about a 25% savings, about a second and a half savings. Now, a more common example here is about 20, 30 seconds, down to about 11 seconds. So we generally get about 30 to 40% savings by doing this. So the fastParse property, a cheap way to do it, you have to select every column and say, I trust this column, I trust this column. A common question I get asked, though, is, well, what happens if a number does, or a date does come in incorrectly then? What's going to happen is it's going to fail later down the pipeline. So it's going to fail somewhere down here when you try to do a data conversion or try to do a drive column transform to add the numbers together. It's going to fail, but it's going to trust you, you're letting the right data through. So one quick hint there on that. So the next piece was really around the network hops. So let me kind of zoom in real quick and let's whiteboard something real quick. So imagine I've got server 1 over here, all right, and I've got a server 2 over here. And I'm just trying to get 6 terabytes of data. Now imagine what is the things that are going to stop me from transmitting 6 terabytes of data from server 1 to server 2. Well, the first thing, of course, at a very minimum, we've got a router right here, a switch right here, excuse me. So we got some kind of switch. All right, there we go. Between that, we also have a network card here, and we have a network card here. So everywhere when you see something in red is ultimately opportunity for slowdown. Okay, so let's go ahead and let's try to chat through this. So let's imagine, for example, I want to get 2 terabytes of data from SQL Server 1 to SQL Server 2, or Oracle Box 1 to SQL Server 2, whatever. So in this example, if I were to go over and grab some data, it's going to go say, okay, SQL Server 1, I want to get some data. Now every step along the way, it's going to check and see how fast can these network cards transmit and how fast can SQL Server transmit along the way. And it's going to come back by default with an answer generally around 4K. And that's not an exact precise number, but let's call it 4K for the time being. That's the bucket that's going to say, all right, that's the network bucket that's going to say it's allowed to be transmitted. So what's going to happen next, it's going to say, okay, here's all different layers and how we're going to transmit on this. SQL Server 2, then it finally transmits that bucket of data, and then I get a peace out saying, all right, I've already transmitted all the data, peace out. Now, there's about 8 hops that happen back and forth as it does this to get that 4K of data that you're seeing right here. So what we can do instead is we can up that number from 4K to something like 32K. The precise number that we're going to see is 32767. So that's the number right here, just in case you're keeping track at home. That 32767 number will make sure that the pipeline that we send back and forth is an adequate number for bigger data sets. Now, when we do that, it's going to ultimately reduce the overall hopping back and forth that we have to do. Now, we're still going to have the same amount of hops per bucket, but we'll have less buckets to transmit. So this only is going to apply for larger data sets. So let's see how we can do that. Let me hop over to a package that has something. Let's just pick one right here, for example. All right. Again, this is one of our packages we'll be using throughout our workshop coming up in, at PASS in the pre-conference. So you'll notice down below, when I go, sorry, let me go back, let's take a step here. I'm looking at the connection manager. Now this is going to apply not only to SSIS, but to analysis services, to a custom application that you're building, anything that has a connection string, this is going to apply to. Now, you don't want to do this for smaller data sets. For tiny little data sets, you're going to find out that ultimately you're going to transmit this huge bucket that's only 1/4 full. But I still have to transmit that 32K bucket if you do that. So what's going to happen when I go to all here, you'll see that the default setting is 0 in this case. What I want to do is I want to change that to 32767. Okay, now this is going to say I want to read data out at a higher bandwidth ultimately. Now, what I've seen now in this case, I was at a customer actually last week, a couple weeks ago, and what we saw was by changing that one setting, there's a few more things we have to do as well. By changing that one setting, what we're going to find is that package, in their case, went from about 3 hours of runtime down to about 1 hour and 15 minutes because they had some network issues in their case. So by doing this one setting, it could be very close to a silver bullet, but it's not quite a silver bullet yet. I have to change that one setting called packet size. After I do that, the next thing I have to do is I have to change the network cards. So every network card that's participating in this package has to be changed. So the source, the destination, and unfortunately the switch or the router or whatever you might have in between those settings. Because in networking, the lowest common denominator is always going to win. So let's go over here and let's change the Ethernet card. So I'm going to change my Ethernet card real quick. Okay, you'll find that's going to be under your adapter settings. And let me go to my Ethernet card real quick. Now, I have a laptop here, of course, so I'm not going to have the full support of 32K of bucket size. In my case, I'm going to look at this property here called jumbo packets. And by default, in my case, it's disabled. So that's not going to be good in my case. In other words, I'm going to be at 4K, essentially. Now, I can go up to roughly 9K in my case. It's really more like 8K, some change there. But we'll basically be able to double the amount of bucket size in our case. So by going from 4K to 8K, we doubled the amount of bucket we can have. So if my connection string said 32K, but my network card said 9014, the 9014 is going to win. So it's whatever the lowest common denominator is across your switch, your router, your firewall, whatever it might be in the way of slowing you down. So if I were to do that, the way you can test this after doing all the network cards and switch, you go over to a command line, and if you just do a ping / question mark, you're going to see you can actually change the packet sizes right here to do a test ping. And one of the properties here is to specify what size packet you want to see. So I'm going to send a buffer size in of X amount of bytes, and if you see packet lost or packet any kind of network errors there, that will tell you have some problems, whether it be your switch or whether your network card or whatever. Okay. Now, what would happen in case if the router or the switch was not set? Is it's going to downgrade you back to 4K. So it's not going to hurt anybody else by raising that jumbo packets or by putting your connection string in there in this case. So what you have to do is you have to go down to the network, down to the basement, the depths of your office, where all the network administrators live, and bring a case of beer to them and beg them to change that packet size to jumbo packets. It's also called jumbo frames sometimes with some of the switches also. By doing that, it's going to ultimately give you a much faster runtime from a networking side. So really, hopefully, good tip there for you. That was close to a silver bullet. They were not making their SLA before, this one customer, and now they're making their SLA. So really cool little internals you can do. Let's talk about one more internals that helps SQL Server a lot. I was at a customer last week, matter of fact, where we implemented this. We find oftentimes with customers that have enterprise edition of SQL Server, they're never using compression. And this is a really, really good feature. So, but it does have some negative impacts also. So why this is in this session is because it's going to have some negative impacts for SSIS, but it's going to help everybody else. So in this customer's case, they were not making their SLA from an analysis versus cube perspective, so their cubes were processing slowly, and they were also having problems with reading data out from a report side. By making this change here, by turning on compression, their reports went from 5 to 6 seconds on average for the fast reports, 20 seconds on average for the slow reports, down to about under 1 second for the fast reports, and 1 second for the slow reports also, because they were I/O bound in their case. So turning on compression, page level compression, if you have Enterprise Edition, makes a lot of sense for a data warehouse or something that's not being updated or inserted into frequently. So if you're inserting to that table, it's going to slow down your performance from an insert perspective. So you don't want to do this on tables in an OLTP environment that are being inserted into on a frequent basis. Now what's making this so much better, now this customer got about 200% improvement in select performance. Amazing. However, from an insert performance, they saw about a 30% decrease. So that's going to affect your SSIS, but they cared about the report performance above their ETL performance. So it's that scale you have to kind of tip occasionally. If you're going to do it, go all in and do page compression, which is basically equivalent of what you do in WinZip. Just so you know where you can find this, you're going to find this right underneath Management Studio. There's some scripts online to test this across all tables. But just going over here real quick, I'm going to go to Task. I'm going to go to Storage of my table here. All right, let's pick a random table here, go to Storage, and you can say Manage Compression. If you do this, make sure you also compress not only the tables, but also the indices as well. So in most cases, if you compress the clustered index, it's going to compress the tables as well, and so just go through and compress all the indexes, and you'll be in good shape there. So there we go. We got, it's only 16 rows, so not worth it, but if I hit the Calculate button, it's going to show the amount of savings. Not a whole lot of savings here. I picked the wrong table in this case. But if we pick the right table, you would see about a 3-to-1 ratio on typically for compression. And what makes it so much faster is now all that data is compressed now into memory, and we're now able to see that data in memory versus having it live on disk. So you're reducing your I/O footprint in this case and making your SAN guy happy, which is very hard to do. So let's go into our transforms next and talk about how we can tune some of our transforms as well. Now, there are some pretty bad transforms in SSIS that you want to avoid. But let's talk about how the pipeline works in general from a scalability perspective. What happens is I fill a bucket of memory. So that bucket is going to be 10 megs of data or 10,000 rows, whichever comes first. When I fill that pipeline up, it's going to escort that pipeline from the first step to the second step. And while that's happening, the next step is already filling up the first pipeline. So even though this looks to be a very synchronous or a very serial process, each of these steps that you're seeing here is working on 10,000 rows. So imagine this is I want to pull. Let's imagine I want to pull 2 terabytes of memory from this customer table down to this row count bottom. What's going to happen is as I'm pulling the 100,000th row from here, let's call it 100K here. We're going to see row 90K being worked on right here. Oh, excuse me, this is the opposite of that. Let's say 70K here being worked on here. So in this case, row 80K will be worked on right here, and row 90K will be worked on right there. So every component is working on 10,000 rows as it's being escorted from step to step to step. Now, this is the truth as long as one thing doesn't apply. Now, that is where this actually works. That they're using is called synchronous component. Now I can break that pretty fast and get traffic like this if I use an asynchronous component. So an asynchronous component comes in 2 flavors, a partially blocking and a fully blocking component. Now a partially blocking component might be like a union all transform or a merge transform. Now picture that old bucket brigade, right, in the 1920s. And as you're scooping a bucket of water out of the well to send it down that fire at the very end, I pass the bucket to you, and you pass the bucket to the next person as you're already getting the next bucket. Now everybody's holding a bucket of water, right? It works out beautifully. Now with a partially blocking transform, keep in mind that bucket is 10,000 rows or 10 megs. With a partially blocking transform, though, what happens is you get the bucket and you empty the water into a new bucket and pass the new bucket on down. Now, why do we do that is because the metadata might change inside that bucket. All of a sudden, it's not a varchar anymore, it's an integer all of a sudden. There's some components that ultimately do that. So things like that union all transform can change the metadata in flight. So it can create potentially new buffers as it comes out. So buffer goes in, buffer goes out. That's one of the problems with that. So there's also a fully blocking transform. Now, a fully blocking transform would be that's when the traffic really happens. What happens is picture how would you sort a deck of cards, for example? If I was to pass you, one card and a 10 card and a 5 card, you can't sort those cards if you're the sort transform until you hold all the cards. Or if I asked you to add up all the cards, you couldn't do that either. So the sort transform and the aggregate transform should be very sparingly used because it can cause some major problems in this. Those are fully blocking transforms. So previously, right here, if this guy right here was a sort transform, before I use that sort transform to go from here to here to here, I only needed about 30 megs of memory for 2 terabytes of data. So 10, 20, 30 megs of memory. However, if I had this guy right here as a sort transform, all of a sudden I need more than 2 terabytes of RAM to make that work. That is not going to be good, is it? It's going to cause some major headaches for your users. So using a sort transform should be used sparingly, and I'll show you ways around that also. So, matter of fact, let me jump out real quick and just hop out and show you some of the ways we can tune that. So what I want to do is I'm going to open up an upsert component here. So let's just kind of go over here to an upsert pattern. All right. So what we're seeing here is essentially I have a source table on the left and a destination table on the right. Now I'm using a merge join, and a merge join could ultimately going to require the data be sorted as it goes in. So not a good case in this case. So one of the things we can do is as we're going in this, we can right-click on this source and say Show Advanced Editor. Before I do that, let me show you the query here. I've already ordered the data in T-SQL and using the power of T-SQL versus the power of SSIS, because I'm trying to avoid that sort transform. So if I were to right-click on this and say Show Advanced Editor, one of the things we can do is going over to this by selecting this green line right here. All right, we'll see, hey, this data looks to be already sorted. There we go. So the is sorted flag is set to true on this column. Then we have to specify, well, how is it sorted? Well, if I select the output columns, one of the columns we see here looks to be that I'm sorting by my transaction ID, and that looks to be true. So you'll notice that every column in this batch right here below that column, in the box at least, had a sort key position of 0, which means I'm not sorting by that column. The transaction ID, however, has a sort key position of 1. And by putting it to 1 means I'm sorting by that column first. If I did -1, it means sorting by that column descending. If I'm sorting by 2 columns, like transaction ID and the product ID, I could do -1 and then 2, for example. So I'm sorting by the transaction ID descending and the product ID ascending. So you can do those things in here as well. Very, very cool kind of way you can do that. Now, the other thing in the data flow to note is how many times you're branching. Now, if you think about this, what we're ultimately seeing here is I have a number of branches. So I have, in my case, 1 branch. I'm going to kind of just count these real quick at a high level. I got a branch right there. I got a branch right there. Now, coming in here, I have a branch as well. Now, if I had a whole bunch of things lined up, like box after box after box, this would only be 1 branch because it's only using 1 buffer essentially being escorted all the way down. But as we're seeing, though, I've got 1, 2, 3, got a 4th branch, a 5th branch, and a 6th branch here. So we have roughly 6 branches of code. Now, each of those branches is going to involve an engine thread inside of SSIS. So one of the internals of SSIS is where I can go to the properties of my data flow and check this out here. What we're seeing is I've got, got a question, Robert?
Yes, I do.
Okay.
Samuel Jones asks, what happens if you use the same number for 2 different columns, referring to the when you were setting up this, which column you were sorting by?
Oh, gotcha. So if I was sorting by those columns, I believe it's going to be a bug. It's going to ultimately blow up at that point. So it will not allow you to do that. Because what's going to happen is it's going to report it in this merge join, for example. You'll see this order right here. It's saying how is it ordering these columns. So if you can't have 2 ones, you can't be ordered by the same column twice. So it ultimately will, you have to have some kind of ordinal position in there that says, I'm sorting by this column first, 1 second. If you do that, it might accept it, but it will cause things to blow up later. Great question, Samuel. Anything else, Robert?
That's it for now.
All right, cool. So the other thing, by the way, in this data flow, if I zoom in on my data flow properties, there we go, we're seeing, first of all, that there's 3 properties that are pretty cool here. One property is how many rows can I fit in a buffer. So right now I have 10,000 rows, or 10 megs, it's 10 megs right there and bytes right there. And I have 5 engine threads. So first of all, let's talk about the buffer size. That number is somewhere between 8 and 12,000, is usually a sweet spot. For a wider table, you may want to adjust it lower. For a very narrow table, maybe you give it a few more rows. But it's a good property to tweak if your data flow is taking a long time to see what's going on. Now, other things you can do is you can, I typically just change the buffer size right here. I don't worry about the bytes there because it's going to find whichever one comes first and it'll ultimately assign that. Now we go into that more in our pre-conference during PASS also. The other thing we do is the engine threads right here are 5. Now you saw we had about 6 engine threads that were needed in my case. However, I only have the number of 5 here. Now what's going to happen is because I have 5 engine threads and that number set right there, somebody is going to stall out. So it's going to read data out of here, going to read data out of here, no problems. We need 3 allocated right now, 4 allocated, and 1 path will likely go forward, and it's going to wait for an engine thread to free up before it goes down the other path. So for every branch that you do like this, you're going to need threads. Now keep in mind, again, just to make sure I reemphasize, if you were to have a whole line of things like this, like that, for example, this is only going to occupy 1 thread. It's whenever you use a asynchronous component where it uses additional threads, or when you branch like I'm branching right here, like multicast or conditional splits. So whenever it needs to create new buffers and send those buffers somewhere else, that's when it's going to do its job there. So again, so the main theme of the story here is if you use an engine thread, if the engine thread is below the number of branches that you have, your package will stall ultimately. And when it stalls, it's waiting for somebody to open up a thread. So it's going to wait for this destination to finish up. And as soon as the destination finishes up, it will allow data to go down the other path also at that point. Okay? All right. Any other questions, Robert, that we have?
Yes, I got another question for you.
Okay.
From Samuel Jones, or I'm sorry, from David Kincaid.
Okay.
Does engine thread equal CPU core?
Yeah, so an engine thread is ultimately going to be tied to a core of some sort. So if you have too high of a number there, of course, this number should only be adjusted if you have things like bottlenecks in your package or data flow where a package is stalling ultimately. So use that number very slightly. But if you do use it, it's ultimately going to increase the amount of CPU that's being used in your box because it is tied to a core ultimately. Great question. All right. Now, another thing to note here also, now this is the upsert pattern. And one of the biggest components that we have inside an upsert component is, as you've seen today, I'm basically making a decision here. Should I insert or should I update? That's what upsert means ultimately, right? So I'm making a decision right here in this conditional split to insert or update. Now, we're not going to go over the pattern and complete here. We're doing that in the, we're going to use that in the, in our past pre-con. But if I were to go to this write component here, this write component is going to update the records. Now, if you recognize this, this is an OLADB command transform. Now, not only is this component hard to use because it gives you like an advanced editor like this, it's going to give you some very gnarly results sometimes also. So the result it's going to give you is it's going to update a row, 1 row at a time. So that's not going to be good, right? So let's make some table changes. Let's really hurt my data here, and let's see how slow this component really is. So I'm going to go over to my pre-con sessions, and let's go ahead and run a quick upsert here. So I'm going to unsynchronize my tables real quick. So I'm going to really mess up my data, and we'll do this in our pre-con also. So I went ahead and deleted about 100,000 rows, and I updated about 800 rows here also. So once we do that, let's watch how fast or slow this data flow goes. So when I right-click on this and I did execute task, let's watch what happens. All right, so what's happening right now is we have a whole lot of yellow right now, right? The data is just kind of stalled. So look at this now. So we have 100,000 inserts, 800 updates, but it looks to be kind of stalled right now. My CPU is going a little crazy right now. little wonky. We have some rows that aren't being changed at all going this path right here, but we're taking a long time to run. So why do you think that is? So if you think it's because this is doing a row-by-row update, you're right. So an OLEDB command transform does updates row by row by row. But not only that, it gets worse. If you think about what is the absolute worst way I can build a component, this will be the way. So I'm doing a row-by-row update. But not only that, but I'm going to open and close a connection for every single row that you pass into that. So we passed in 800 rows. We saw 800 updates going into this. So this is the equivalent of a cursor that's even worse than a regular cursor. All right, Robert, what do you have there?
Martin Kearney asks, in the not changed part of the upsert pattern, if we do nothing with that output, i.e. don't expose it to another object, would that still need another thread?
Oh, I see. Yes. So great question. So his question ultimately is if I just put this for demonstration purposes, but if I just let go of it, if I just delete this component, it would not use an engine thread. Right. Right. So good question there. So what we're seeing again, it's going to do a row-by-row update, and it is going to ultimately open and close connections. So one of the ways we can speed this up, we say this saying this now, we'll put lipstick on a pig, right? This is a pig. This is a pig in its worst source. So let's find a way to put lipstick on it and make it look pretty. So what we can do is if I pick the connection of where this connection right here is ultimately updating into, which is this guy right here, for example. If I were to go to the properties, now it's an advanced property, you won't find this in the connection manager. But when I go to the properties of this connection, one of the properties, oh, there we go, it's a little hard to see there, is retain same connection right here. So again, you single click on the connection, hit F4, and you'll see retain same connection. Now by doing this, it's not going to open and close a connection. It'll keep the same connection open during the whole duration of the packages. Now by doing that, it's also going to, you should only do that if you have this kind of pattern. Because you don't want to keep that connection open during the whole package if you didn't have this kind of problem. So it's because SQL Server is really good at doing connection pooling and those kind of things. So let's see how long this took to run. This took about 24 seconds to run in my case. Now, sorry, there we go. Zoom in a little closer. 24 seconds. Now, that retain same connection property would shave up about 30% on that runtime probably. Okay. Let's see how we can make this a little better though. One of the ways we can make this better is with a slightly different approach to doing data flows. Okay, oop, that's not it. There we go. Let's go over here to, oh, there it is. All right. So this is essentially the same data flow. Don't ignore basically what's happening up top here. What it really comes down to is this update now. The update's happening now. In this case, I'm inserting my update. So I've got an OLEDB command, OLEDB destination here, and I'm inserting my updates. So why does that matter? Well, now that I'm inserting my updates, and I got you, Robert, after I do that, I do a set-based update in the control flow to ultimately use T-SQL for what it's good at. Would be merge T-SQL syntax or update T-SQL syntax. I'm basically inserting into a staging area and doing a set-based update to do a big update in the SQL Server. Robert, what you got?
Amir Charania asks, could you do this entire transform in a SQL Server stored procedure, and would that not be faster?
All right, it's a great question. So let's first of all see how fast we're talking about here. And I'll make sure I answer Amir's question here. So we were at what, 27 before, I believe, Robert? Let's see here. 24 before. So 24 seconds before. All right, so Robert, what do you think? What do you think this is going to be at now if you're a betting man? So what we did is we basically took a row by row, took a cursor out essentially, and now we're doing a set-based update instead. So what do you think, Robert?
I think it's going to be extremely fast now.
Ah, you're no fun. All right, so let's find out how much faster it's going to be. From 24, go ahead at home, write your number down. So 24 seconds, and well, let me stop the package first of all. I haven't made the updates first. Let me go ahead and make it be fair here. Let me go ahead and delete this 100,000 rows again. All right, here we go. So 24 seconds down to, oh, look at that. All right, so same updates, same inserts, all this occurred from 24 seconds down to about 2 seconds. So much, much, much faster. And I probably wasn't on GoToMeeting right now. Normally it runs about less than a second, actually. So somewhere around, what, 500% savings there? Huge amount of savings, 95% savings there. So the question from Amir, though, was, well, you're doing a lot in T-SQL here, Brian. You know, when does it make sense to use SSIS versus T-SQL? Well, in this case, it really depends. It really depends, right? What we have to assume here is this data is from a spreadsheet, for example. So this data might have come from a flat file or a spreadsheet. So I don't have the luxury of doing T-SQL in this case. Also, what if I had different servers? You know, I'm pulling data from server 1, which may be a staging environment, and merging it with data from server 2, which might be a data warehouse. But different servers, and these land in different places. In those cases, you can't do T-SQL. So it all depends. T-SQL has a place. As you saw, it had a great place in this case. But if I'm lifting data up and I see a whole bunch of transforms, let's imagine this wasn't just 2 things I was doing, but maybe 30 things I'm doing. In those cases, T-SQL would probably underperform because I'm having to cause a lot of I/O as I'm updating on a SQL Server disk. Instead here, if I'm doing these transforms in memory, it's going to be much better to run through it in SSIS. So it really depends on it's a really deep question, Amir, that I'm not going to give it much justice here, unfortunately, but you're right and I'm right. It all depends on the situation and how many transforms you're doing inside of that. All right, cool. So it's a great question, though. That's really the core question that's hard. The other question I often find is, well, how do I know when I'm running out of memory? You know, when do I know that enough is enough? Well, if I were to go over to, let's just do call perfmon here. All right. I'm going to open up perfmon, and let's find out. We might go a little more than 15 minutes. I think, here we go. So if I hit the plus button here in perfmon, let's see here. Well, the counter I'm looking for is going to be SQL Server pipeline events right here. So you want to tell your network administrator that you want to put a watch on buffer spooled. If that number right here, let me kind of zoom up a little bit more here. There we go. So you can see the full counter here. If this number ever goes above 0, you have essentially run out of memory on your SSIS box. You are now spooling things to disk, and at this point, what you're going to find is a package that might have taken, 15 minutes to run, might now take 2 days to run. It's that big of a difference, because all the benefit of SSIS, of being in an in-memory architecture, is now out the door. So really key counter to watch. Buffer spooled is your red light. And there are some yellow lights in here also, like buffers in use. Robert, any questions?
One comment from Samuel Jones. Follow-up to Amir's question about using a stored procedure. He comments, there's always SQL CLR for importing from these sources.
Right, from flat file, there's always SQL CLR, absolutely. But I definitely think, using like I'll give you that. So SSIS should perform better, though, over CLR, importing data out and transforming it, but it all depends. There's definitely cases where I've been proven wrong, though. All right, so what we covered in this little piece here was how do we tune our transforms. Let's jump back over to our slides just for a few slider here, too. Okay, so I'm going to kind of need to ramp up here. So let's talk about where we can run our SQL Server. Most people prefer to run SSIS on a dedicated box in some cases, if the licensing is allowed. Now, if you do that, one thing to note is as I'm bringing data from SQL Server 1 to SQL Server 2, I'm causing a network hop. So if I bring data from over here or over here, ultimately we have to worry about it drowning my SQL Server. Well, if you do that, one of the tools you can use is called WSRM, Windows System Resource Manager. And it's a feature you turn on inside of Windows. It's already built into Windows, and it can monitor how your SQL Server is doing, or your SSIS is doing. You can allocate resources basically like a governor and say, at nighttime, SSIS, you can have 50% of my resources. But during the daytime, SSIS, you can only have 10% of my resources. And you can actually go through and say, all right, during the daytime, I want to go ahead and make sure that if it's allowed, if I have enough resources allowed, then SSIS, you could have more as long as I have the resources. But as soon as SQL Server needs it back, it's going to push SSIS down again. So really kind of cool tool around that. The other thing we can do is we can scale out SSIS. So I'll end it right here. So basically this is called the work pile pattern. Now the work pile pattern is where I basically create an SSIS task queue, and I say, all right, SSIS, go ahead and grab me some work. Each one of those SSIS that you see running right now are going to get a piece of work and work that piece of work. After it works the piece of work, it's next piece of work. It's a basically way of scaling out SSIS for moving large amounts of data over a network when you appear to be bound. So what this does basically is if I have a process that takes, in this case, 64 seconds to run, with each process running in serial fashion, loading a file, loading a file, loading a file, let's call about 64 seconds. If I can run 2 processes, ultimately I can trim that time almost in half by doing that. Now you will reach diminishing returns the more processes you run, because ultimately as you do this you're going to run out of cores, right? So in my case, my laptop with 2 cores, I was reaching diminishing returns the more and more I ran in parallel. So what that looks like is this. I have a queue table that looks like this. Let me kind of just open up. And we cover this a lot more in our pre-con, by the way, also. So in my case, I'm going to open up my task queue table. And you'll see in my case, what I'm doing is I'm looping over a whole bunch of files. Now, instead of files, this could be customers that you're looping over. It could also be a where clause. So I could see data like 2004, 2005, 2006, and so on in this. You want to make sure that each of these slices, though, matches a partition on the table that you're reading from. That way you can read out of multiple files all at the same time. So if I were to do this, what's going to happen is I want to run where all of these are going to run at the same time and not be constrained by just a very serial process. So your package will look like this, and we'll provide these at the pre-con also, by the way, or whenever. But if I look at this, I've got a package here called worker right here, and I'm doing a loop. And ultimately, I'm getting the work item to work on from the work pile. I do the work, and then I check the work back in. Now, as I check this work out right here, I'm causing a lock on that work, so nobody else can grab that work at that point. So lots of stuff can happen. I can loop over all these at the same time now by doing this. Now, I can fire these packages off in PowerShell, or I can just go over to the good old-fashioned DOS here and fire them off from here as well. So what I've got is I've got a batch file called called spawnworker.cmd. And what's going to happen is you can ignore most of the script here. All you care about is this line and this line. I'm going to pass the number in from 1 to whatever, and it's going to replace that. It's going to kick off this package X amount of times. So everything, all of the code there is kind of prep code. So if I type in spawnworker.cmd, and I'll type in the number 1 right now, we'll see the package go right down below here. And we're seeing my CPU hover around 75% because I'm on GoToMeeting right now. So it's eating up a little of my CPU right now. So I have some spare CPU to give right now, and I really want to see that package there run faster and use more of my CPU. So it looks like, let's see how long this took to run. It's still running, and if I go to my store procedures here, I've actually got a store procedure that will tell us how long this took to run. All right, still running. Wow, there it goes. It just finished up. The whole thing took about 30 seconds to run because of GoToMeeting kind of in the background. So let's try 2 processes now. There we go. We're now seeing 2 of these run in parallel. We're seeing my CPU now perk up a little bit, and now I'm using about 90% of my cores, 80% of my cores, and we should hopefully see this run a little faster than 30 seconds. So I am running a little bit latency here right now, but let's see. Okay. Robert, while this is going, okay, here, that's actually all done. Excuse me. Let me guys see this again. There we go. So it went from 30 seconds down to about 19 seconds. So we saved about 30% on making this one change. The cool thing is we could run this on n number of servers. It doesn't have to be just one server running one package here. There's lots of cool stuff we can do with this. All right, so I'm running 4 now in parallel. Now I've definitely reached diminishing returns. I've capped out my CPU. I only have 2 cores to give, and I'm using all 4 cores now. And I'm using all of my box now, so chances are we've reached diminishing returns. We might see even a negative result now by doing that, and we save 2 seconds is all we save in this case. So let me go back over to our slides to kind of wrap up here. I know we're going to have some time for questions here as well. Robert, what kind of questions do we have here so far? So while Robert's kind of looking at the question.
Not quite sure. I'm not quite sure whether this is a question or a comment, but Tony D'Amico says, T-SQL setup connections to different servers and then references DB schema object on different boxes. Not sure what Tony is asking for there.
I'm not sure either. I'm sorry about that, Tony. If you want to clarify that, please feel free to clarify. You also have my Twitter handle here, or b9@pragmaticworks also. What else we got, Robert?
I've got one question that's a little bit off topic, but a little bit related. Shashi Taluri asks, DB2 to SQL Server using SSIS OLEDB driver versus the ODBC driver. Which one is recommended?
I've used the Microsoft one, which is very, very good. The provider that's part of the feature pack, if you have Enterprise Edition, is very, very good. It handles multi-threading better than even the DB2 provider does. So from SSIS perspective, I use the OLED provider for DB2 that's part of the feature pack, and it's basically their licensing host integration services for you. So it's a really, really good provider, and it's very, very fast. But make sure if you have your pulling cloud data out that you set that network packet size also. So you'll find that property again. If I go back to my connection string here, you'll see once you set it, it's meter all here, but you'll find it under right here, 32767. You'll also find it in the properties in the connection strings. When I kind of hover over this, you'll see the connection string will actually have it there as well. And DB2 has that property as well. It's like network packets like that. There it is. Okay, what else you got, Robert?
Brian White asks, is there a recommended perfons to set up to monitor SSIS box versus transactional SQL Server box?
So as a regular perfmon counters to look at, well, that one I mentioned before is the biggest one to do. There's also other buffer ones you can watch. The buffers are the one things you care about. The buffers are the ones that ultimately monitor how much SQL Server memory, how much SIS memory is being consumed, and if you're constrained by that. If you run out of memory, keep in mind, your packages will go down in performance pretty sizably. Again, 10 minutes down to 3 hours all of a sudden. It's ridiculous how much of a difference there is.
And next, Damien O'Connor asks, I've done stuff like the queue before and found generally I've had to use row lock and read past tense to get the queue to work properly. Have you found that? How are you otherwise ensuring no work is repeated? Thanks.
For the queue processing or for SIS? What do you think, Robert?
For queue processing.
Okay, for rollup, I can see where that might be an issue. But I typically rollup, I won't have too large tables because it doesn't perform very well. So those are usually for my very small, today's partition kind of view. So it's more a pretty nuanced question. But please feel free to email me after this, and I can discuss it more with you.
And David Kincaid asks, it depends, but any recommendations on performance tuning script tasks and components?
Oh, great. So it does depend, of course. A built-in component will most of the times run much faster than a script component will. So as a coder, you have to kind of resist the temptation to use script components. You want to use a canned component if at all possible. Because it's written in assembly and C++, I mean, it's written some pretty hardcore code behind that. But you want to make sure that it depends, there are some very nuanced scenarios there. One of the things you want to watch is, and we actually covered this in our pre-con, by the way, also. You want to make sure you're not only locking the variables for certain periods of time. There's lots of stuff to make sure that you don't, that in your pipeline rows sent method, that you don't put too much code inside that. You don't put any kind of initialization code in there. That's going to run for every single row going through it. So you have to be kind of careful there. It gets a lot more nuance than that, so I'll probably leave it at that right now. But if you like, it's also going to be in the pre-con as well. Okay, what are the questions? Anything else, Robert?
And next, Shashi Taluri asks, any recommendations for improving performance while writing data to flat files?
Okay. What I heard there is any performance differences from writing data to flat files, and on that there's lots of stuff you can do there as well. The big thing is you want to make sure that flat file is on a good disk. I mean, it's really about core just DBA kind of tuning, right? A solid state drive is always going to perform better. You also want to make sure that in your connection manager, like this guy right here, for example, that we're only using the data types that we really care about. So in here, for example, I don't have the default. It's going to be string 50, and I've already tuned these down to just integer. And by doing that, it's only going to use 4 bytes per column of memory versus the 50 bytes of memory that's the default. So you'll make sure you've tuned this connection manager for your flat files down to just what you need instead of everything else. Great question.
And next, Amir Trania further asks, how do you ensure that get task that gets work from the queue does not get the same task for 2 tasks? How do you use transactions for that?
Yeah, so what I've done in my store procedure is a store procedure called get task here. It ultimately, as it selects, it also checks the work out. So there's a select and an update at the same time. So it locks that down. You'll see it right here. It's not the most elegantly written one, but it works pretty well. So I'm doing an update and a select all at the same time here. So I'm getting the row out that I need. And so that helps me ultimately make sure that only one guy can check that work out. Now we use this in our case. There was a large power company that had about 30,000 files to process, and they could not process it in time. So what we did, and we had another customer that had to move 6 terabytes out of DB2 into SQL Server. They could not move that over a weekend maintenance window. So by doing this task queue, a work pile pattern, in other words, you're able to ultimately make compress your schedule down. That power company ultimately runs the packages on about 10 different SQL servers now, or SSIS servers. It's always processing these files. So 30,000 files an hour going through, and they have 10 SSIS machines all churning through that. Anything else, all right? We're almost down. We're down to like the last 2 minutes, I think, aren't we?
Yes, and next question, and I want to apologize in advance for mangling the person's name, but Azakapan Arunachalam says, can we use fast load and data flow when using transactions? The table gets locked up, and if we set it to no fast load, it works fine. Any suggestions to have fast load in a transaction required scenario?
Great question, and I was hoping to cover that if I had time. So I'm glad you asked that question today. So let me just open up a data flow here, and let's talk about what he's asking here. What he's referring to is this fast load option that you see right here. This should almost always be set if you trust your data. If I set it the default way, table or view, what's ultimately going to happen is it's going to do a row by row insert. That's a default way. It's the default way for things like the slowly changing dimension, a few things like that. It's going to do a row-by-row insert ultimately, a cursor. If I were to go to a fast load, it does a big bulk update, and it's going to ultimately send 10,000 rows at a time. This is the buffer size right here, into my transaction log. Now look at the default here. The default is it's going to commit the data after 2.1 billion rows. So you're going to see your SQL server all happy-go-lucky, and you're like pounding it to death, right? You're like sending billions of rows in or millions of rows in, and it's all happy. Then all of a sudden, the 100th millionth row goes in, and your last row goes in, and it commits, and your SQL server goes to its knees. So first of all, you want to adjust this number down from somewhere around 2.1 billion or 0 to somewhere around 100,000, maybe anywhere from 80,000 to 250,000, based on the width of the rows. Wider tables, lower the number. Narrow tables, the wider number, so a higher number. So, but 2.1 billion is definitely not the right answer. Now, his question was really around transactions. So he has transactions turned on right now. He has the, and we covered this in our pre-con also, but he has transactions turned on a few ways, probably over here under the implicit ways here inside of MSDTC. So I would argue at that point it probably doesn't make sense to do DTC transactions if you have that many rows. It probably makes sense to do something different, a little more elegant solution, maybe a little different solution, and it might be maybe a snapshot backup where you can restore it very simply after all the rows going through, some simpler way of kind of rollback at that point. So there's a whole bunch of ways of doing it. We cover about 3 or 4 ways in our pre-con, but I think probably a snapshot backup might make more sense based on the number of rows it sounds like you might have.
Thank you, Brian. We're out of time for today. If you like what you heard here, Brian will be presenting at PASS Summit 2014. Catch him in the pre-conference where he will give a full presentation of the SSIS problem design solution and real-world lessons about starting a consulting company. And don't forget to use the discount code 2414 to save $200 on PASS Summit registration. Stay tuned for our next session, Availability Groups versus Failover Cluster Instances. What's the difference with Alan Hurt, happening momentarily. Thank you.
Thanks, guys. Thanks, Robert.